Spotted near Giga, Texas, the long-awaited Tesla Model 2 finally made its debut, not at a gala event or with fireworks, but amid the metallic clang and smoke of the assembly line. Covered in heavy camouflage, the car seemed intent on hiding its secrets, but not everything went unnoticed by the most observant eye. Judging by its proportions and silhouette, it's clear we're looking at a compact hatchback, with a much more urban and streamlined profile than its older siblings. The idea is simple, yet powerful: to put an affordable Tesla on the streets, breaking the psychological barrier of $11,000, something unthinkable just a few years ago. And we're not talking about a bare or personality-free electric car, but a model that promises to surprise. The timing of this project couldn't be more strategic. While competitors are trying to balance technology and cost, Tesla is aiming straight for the mainstream market, seeking to make the Model 2 the first electric car for many people. About 25% smaller than the Model 3, the Model 2 presents itself as the answer for those looking to ditch fossil fuels, but without entering the world of luxury EVs. The secret, at least for now, lies in the combination of scale, automation, and tax incentives, which together push the final price to around $10,799. And that's with the benefits of the $7,500 federal credit still in effect. But this offer won't last forever, and that's where things get interesting. The so-called beautiful bills, a set of legislative proposals that could come into effect starting in 2026, threaten to cut this benefit, making the same car significantly more expensive in the blink of an eye. This creates a very narrow window of opportunity for those looking to get ahead of the future. What's at stake here is not just a new car, but early access to a new era of electric mobility, one in which price will no longer be the biggest barrier to entry. Behind-the-scenes movement at Tesla indicates that the Model 2 could be a game-changer in this regard. But affordability only makes sense if it's delivered. And, looking closely, the Model 2 appears to have been designed precisely to balance cost and design intelligence. The rear end, with nearly vertical glass, the short hood, and the highly aerodynamic front end, are clear signs that every inch was optimized. The wheels were designed with efficiency in mind, minimizing rolling resistance. The lightweight body, at around 3,200 pounds, shows that weight was also taken into account. This combination promises not only economy, but also drivability and comfort in urban areas, where space is at a premium. All of this reinforces the idea that the Model 2 isn't just here to be affordable. It wants to be useful, practical, and competitive. What the first glimpses reveal, in fact, is that the Model 2 is far beyond a theoretical project. It's already a prototype in advanced testing, driving around Giga, Texas like someone who knows the route. Elon Musk confirmed that the schedule remains on track. Final testing in 2025, pre-production in the third quarter, reservations at the end of the year, and mass production early in 2026. And if plans are maintained, it won't arrive slowly. It will arrive with a force of up to 500,000 units per year in the first cycle. And that changes everything. What really makes this car promising isn't just the price, but what's hidden under the hood. The Model 2 will debut the second-generation 4680 structural batteries, a technology that's attracting attention not only for its performance, but also for its proposal to completely rethink the way electric vehicles are built. These batteries aren't just power sources. They're part of the car's very structure, contributing to chassis rigidity and reducing overall weight. Using LFP, lithium iron phosphate, chemistry, they offer a safer and cheaper alternative to traditional nickel-based batteries. And best of all, they don't rely so heavily on Asian suppliers, which has been a headache for the industry in recent years. The estimated range of 350 miles, which is over 560 kilometers, is a pleasant surprise for those expecting something more modest from an entry-level model. This puts the Model 2 above many direct competitors, such as the Chevy Bolt EUV, which averages 280 miles. This range is more than enough for most daily commutes and still leaves room for a weekend trip. This feat is a direct result of the combination of the new batteries, the aerodynamic design, and the structural weight reduction. It's as if Tesla squeezed every drop of efficiency possible to deliver the most with the least. Acceleration doesn't disappoint either. The Model 2 is estimated to go from 0 to 100 km/h in around 6.9 seconds, comparable to entry-level SUVs from BMW or Mazda. This shows that, despite its affordable approach, the car hasn't forgotten the driving fun factor. The sensation of instant torque, typical of electric vehicles, remains here, but with the added bonus of not needing an executive salary to experience it in practice. And while top speed isn't the focus, the predicted 110 mph, about 177 km/h, is more than enough for a smooth ride on American highways, or even a dignified Autobahn adventure. Another noteworthy detail is compatibility with the new NACS charging standard and support for V4 supercharging, which promises a 10% to 80% recharge in less than 25 minutes. This completely changes the user's relationship with the car. Waiting at the charging station, which previously seemed like a chore, practically becomes a coffee break. This agility makes the Model 2 not only a good urban option, but also a viable vehicle for longer trips, something compact models often can't offer without hassle. And none of this would be possible without a project that prioritized integration from the start. Tesla isn't just adding larger batteries or tweaking software. It's restructuring the way we think about a budget electric car. The choice to use an architecture that combines structural batteries, aerodynamic design, and lightweight solutions isn't aesthetic. It's pure strategy. Every decision was made with the goal of delivering maximum performance at the lowest possible cost. And this philosophy goes beyond engineering. It dictates how the car will be produced, tested, and soon sold on a global scale. To understand the Model 2's true impact, we need to look beyond the car itself and observe what's happening in the guts of the factory. Tesla is about to launch one of the greatest industrial revolutions in recent history, with its new production method called Unboxed. The idea here is not just to improve what already exists, but to turn manufacturing logic on its head. Instead of the classic linear assembly line, where the car receives parts as it moves through the factory, Tesla decided to break the car into large modules: front, rear, battery, and cabin, and assemble everything separately. Only then are these blocks assembled at the end. It sounds simple, but this change reduces the required physical space in the factory by more than 40%. This new model not only saves space, but also drastically shortens production time per vehicle. The goal is to achieve less than 10 hours per unit, which is much faster than the 25 to 30 hours it takes traditional automakers to assemble a combustion engine car. Even Tesla itself, with its more streamlined production, still spends between 12 and 14 hours on the Model 3 and Y. Cutting this time almost in half means not only delivering more cars, but also cutting labor, energy, and internal transportation costs. This, of course, without sacrificing quality, which, by the way, could even improve. Quality, in fact, has become an obsession. Tesla is using artificial intelligence-enabled cameras and machine learning systems to scan every weld, joint, and part of the car before it moves on to the next stage of assembly. This reduces quality control bottlenecks by over 70% and raises the immediate approval rate to nearly 98%. Highly precise robots handle tasks like painting, multi-axis welding, and component fitting with sub-millimeter precision. And because the software that controls these robots is developed in-house, updates and corrections can be made weekly, unlike the traditional model, which requires costly physical reprogramming. One of the greatest assets in this process is the famous 9,000-ton Gigapress, a casting machine that transforms hundreds of small, welded parts into a single solid aluminum block. With it, entire sections of the car's undercarriage are manufactured in a matter of seconds. Fewer parts mean less chance of error, less assembly time, and a more durable car. With each cycle, the Gigapress delivers a part that requires up to 60% fewer inspections than a conventional undercarriage. And when you're talking about producing millions of units, this represents a huge savings. All of this fits into a larger plan, where efficiency, speed, and scale go hand in hand. The Model 2 isn't just the final product. It's the result of a production philosophy that's being shaped live. Tesla is building a new factory within the factory, with robots, AI, giant foundries, and software that communicate with each other like an autonomous organism. The goal is bold, to reach 2 million units per year by 2027. But the way the wheels are turning, that number may not be a distant fantasy. It may just be the next logical step in this relentless engineering endeavor. Tesla's global machinery doesn't revolve solely within a single factory. In fact, Model 2 production was designed as a synchronized operation across several gigafactories spread across the world, each with a specific function, as if they were organs of a single body. Giga Texas, for example, is the nerve center of final assembly for models destined for the North American market. It's there that the large modules, produced in different locations, meet to form the complete car using the Unboxed process. The goal is to transform this plant into a true stage of efficiency, where everything happens in the smallest possible space and in the shortest possible time. Meanwhile, Giga Nevada plays a strategic role, mass-producing the 4680 Gen 2 batteries, the heart of the Model 2, with a $3.6 billion expansion. This facility will be capable of producing up to 100 gigawatt-hours per year, enough to power 1.5 million Model 2s. The facility was designed to operate on a just-in-time basis, meaning the batteries leave Nevada and arrive ready for use at the Texas assembly line. This reduces inventory, avoids waste, and streamlines production. This integrated logistics is one of Tesla's greatest assets in scaling the model at a reduced cost. Across the Atlantic, Giga Berlin is springing into action to serve the European market. This facility, which already assembles the Model Y, is being adapted to include the new 4680-based architecture and Gigapress casting systems. The idea is for the Model 2 to meet all European Union regulations without the need for complex adaptations. Manufacturing locally, in addition to saving on shipping costs, allows the car to qualify for regional incentives and tax credits. And this, in a highly competitive market like Europe, could be the decisive factor in the car's success against rivals like Renault, Volkswagen, and Fiat. But the biggest bet of all is a little further south, in Giga Mexico. This project, which will consume more than $15 billion across several phases, is being built from the ground up to become the global production hub for affordable models. The location is no coincidence, close to the US border, but with easy access for export to Latin America, Europe, and even right-hand drive markets like Australia, Japan, and the United Kingdom. There, everything will be designed around the Unboxed line and full automation, with next-generation robots taking over processes that previously depended on dozens of human operators. This multi-factory approach also ensures flexibility in the face of potential bottlenecks. If there's a parts shortage in one region, production can be reallocated. If demand explodes in a specific market, capacity can be quickly reallocated. It's like a living organism adapting to environmental conditions, and in this case, the environment is the entire planet. With factories that share parts, systems, software, and infrastructure, Tesla aims not only to deliver the Model 2 to the world, but to do so in a coordinated, scalable, and, above all, profitable manner. A symphony of steel, data, and clean energy.